My name is Fred Dillon, and I'm going to be discussing measures of dispersion and center. There are three measures of center. The first is the mode. It's generally best for categorical data, which means it's used for things like eye color or gender. It's unstable, and it can be easily changed by adding terms. It is the term or number of terms that occur most often. Next is the median, and that is when the data is in order, it's the middle of the data. The best thing about the median is it is not affected by outliers and is called stable. Finally, we have the mean. The mean is the sum of the data divided by the number of data terms. It is the most commonly used measure of center. It uses all the values, but is easily affected by outliers, which causes it to be unstable. The mode is the most appropriate for categorical data. In this graph, you can see we have different eye colors. Finding the arithmetic mean or median of a list of eye colors is impossible, so the mode is the best measure of center. The median is based on putting the data in order and finding the middle. If there's one term in the middle, that is the median. If there are two terms in the middle, we average those two terms together by adding and dividing by 2 to get the median. When we want to look at the median versus the mean, we'll have to have some data. The data here is about the average lifespan for women in different countries. This graph shows that we have a wide range of data with a great deal of data clumped at one end and a long whisker on the left end. This means that we would have a difference in the mean and the median. The median is 81, which reflects the middle more accurately than the mean in this case, which is 74.5. The extremely low values for Zambia and Haiti have strongly pulled down the mean. Next, there are the measures of dispersion. These are the range, the interquartile range, and the standard deviation. The first of these is the range, and we'll be using our same data using the average lifespans for women. The range is calculated as the largest value of the data in order minus the smallest value of data. The range is reported as a single number. In this case, we have a maximum of 82 and a minimum of 51. The range is their difference, which is 31 years. To find the interquartile range, we have several steps. The first is to put the data in order and then find the median. In this case, there is an even number of data, but the middle two terms are both 81. The sum of 81 plus 81, then divided by 2, is 81, so the median is 81. Next, we need to find the median of the lower part of the data set. We split this at 81 and count the data and leave it in order. The middle number this time is 79. We refer to the median of the first half of the data set as quartile 1 or Q1. For the upper half of the data, we find the median as well. In this case, it is 81, and we say that the third quartile is Q3 or 81. The interquartile range is the difference of the third and first quartiles. That is, IQR, which is the abbreviation, equals Q3 minus Q1, which is 81 minus 79, which gives us 2. Did the low lifespan of Haiti affect the interquartile range? It did not, because that was one outlier that did not affect things. If another country was added that had average lifespan of 100 years, would that affect the range? It should not. One high value would not affect the interquartile range. The interquartile range is helpful because it identifies the middle 50% of the data. It is also useful because, as we just saw, one or two outliers, a few data points that are far away, did not affect the median. The most commonly used measure of dispersion is the standard deviation. We're going to use the data set for lifespan of women again, and we need to think of the standard deviation as the average distance from the mean for each data point. The mean of this data set is approximately 77.6 years. We want to see the average distance each point is from this mean, so we will subtract the mean from each data value. You can see in the screen here that we have taken each value and subtracted, getting some positive values and some negative values. To find the average distance from the mean, we would add these together. You can see in this chart that we end up with an extremely small number. If you think of the mean as the balance point of all the different data values, by taking values above and below, the sum should always be 0. The reason the sum is not 0 here is merely due to rounding error. So we need to get rid of having that 0. One way we can do that is to square each of the differences. So in this chart, we have taken each of the differences and squared them, removing the effect of the sign. Then we take the sum, and we get the sum of the squares of the differences to be about 887. The next step is to find a value that's called the variance. The variance is the arithmetic mean of the sum of the squares. In other words, we take that sum and divide it by the number of terms, in this case 14, and we get approximately 63.4. Now we have to undo the squaring. By undoing the squaring, we have taken this to become the standard deviation. And the square root of 63.3878 is approximately 7.962. The standard deviation is labeled as sigma sub x, and it can be found using this formula. The formula has sigma sub x equals and then a square root sign. Underneath that, you'll see a symbol you may not have seen before, which is a sigma sign, which means you're going to take a large addition problem. It's a shortcut for writing down all of the different addends. It says we go from I equal 1 to n, which means we will put in numbers in order 1, 2, 3, 4 in order of the terms. X sub I refers to the number of the term. It's then subtracting the mean, which is x bar, and squaring it and dividing by the number of terms. We're frequently interested in the standard deviation because we want to know the percent of data that is within one standard deviation of the mean. We also look at the size of the standard deviation relative to the size of the data. A large standard deviation in relation to the data size indicates an extremely large spread of the data. We're going to look now at using a calculator to find the measures of center. First, you need to input data, and we'll use the data set 7, 10, 13, 3, and 6. On a Texas Instruments calculator, this data should be put into list 1. We're then going to use the following keystrokes so that we can find the summary statistics. And that is that you'll press Stat, arrow over to Calc, and then go down to number 1 and hit Enter. The resulting screen shows you X bar and a lot of other statistics. Some of these are that the range can be found by using the max and min values and subtracting them. You can find the interquartile range by subtracting the Q3 and Q1 values that are given. And the standard deviation is indicated by sigma x. If you need to find the variance, you can just square the standard deviation. And in summary, what you should have learned today is what the different measures of center are and when they can be used, what the different measures of dispersion are, and specifically how to calculate the standard deviation.